ACS ready
29.
for launch.
Roger.
Minus 25 seconds.
Status check.
Go Atlas.
Go Centaur.
Go AEHF.
This is Atlas Mission Control at T-minus 10, 9, 8, 7, 6, 5, 4, 3. We have ignition. And we have liftoff of the United Launch Alliance Atlas V rocket carrying AEHF-3 for the United States Air Force. Advanced EHF satellites provide a tenfold increase in capability to our troops in the field. You will now be hearing the voice of Marty Malinowski providing launch vehicle ascent data. Let's listen in for mission progress.
SRB chamber pressures look good. Roll program is complete. And boosters throttled down, right on schedule. Mach 1. Max Q. And boosters throttled back up, right on schedule. Engine response looks good. Pump speeds are good, injector pressures as well. Booster Q has gone to closed loop control. Engine response looks good for the set mixed ratio. SRB chamber pressures have plateaued, looking very good. Coming up shortly on SRB burnout. And SRB chamber pressures are beginning to roll over. We have burnout. Current altitude is 20 miles, downrange distance 19.5 miles, current velocity is 3,441 miles per hour. And the booster is throttled down again as scheduled. Engine response looks good, pump speeds are good, injector pressures are within band. And we have SRB jettisons. Closed loop steering has been enabled. Vehicle response rates look very good. Current altitude is 41 miles, downrange distance 66 miles, current velocity 5,384 miles per hour. Range track looks good, right down the middle of the corridor. RCS pyro valve has been fired. That system is now pressurizing up to flight levels. Signatures look good. Currently accelerating smoothly at 3.1 Gs. Current altitude 59 miles. Downrange distance 120 miles. Current velocity 7263. Range track continues to look good. Booster has throttled down for payload frame jettison. And boosters throttled back up. Now throttling to maintain 4.6 Gs. Boost phase chill down is underway. And we have retros and stage separation. We have LOX and fuel pre-start. GN2 purge firing is completed. We have ignition and full thrust on the RL-10. Centaur steering has been enabled. Very light disturbances on the vehicle at this point. Fuel, the LOX tank has been vented down as expected. Centaur PU has been commanded to fixed angles for the early portion of this 567-second burn. Chamber pressures look good. LOX pump discharge, fuel venturi, all appropriate for the set mixed ratio. Current altitude is 130 miles, downrange distance 546 miles, current velocity 12,901 miles per hour. Coming up on our thermal conditioning firings for the RCS, we have our first firing. Signatures look good. Line temperatures continue to warm towards bottle temperatures. Should be within range of Antigua at this point. Centaur PU is now controlling to closed loop control, however it continues to request an oxidizer rich condition. This is expected.
This is Atlas Mission Control at T+6 minutes and 18 seconds into the flight. We've just heard Marty Malinowski report the successful execution of the events comprising the early part of today's mission, and all systems continue to operate nominally. The mission is currently in the first of 2 Centaur engine burns. Our next event, the Centaur main engine cutoff, will occur in approximately 8 minutes. I'm now joined by Captain Jennifer Ferrer of the U.S. Military Satellite Communications Systems Directorate. Captain Ferrer, welcome and thanks for joining me.
Thanks, Steve. I'm thrilled to be a part of the mission for the next advanced EHF satellite. The third mission is very critical to our nation.
I was wondering, as you just mentioned, this is the third advanced EHF satellite. When were the first 2 satellites delivered, and how will this third satellite increase our nation's capabilities?
Well, the first satellite was delivered in May of 2010 and the second in August of 2012. In addition to the first 2 satellites, the third satellite will provide assured, protected, and survivable communications for our nation, as well as our international partners, such as the United Kingdom, Netherlands, and Canada. Each advanced EHF provides 10 times greater throughput than its predecessor, Milstar. Additionally, advanced EHF satellites can cross-link with both Advanced EHF as well as Milstar satellites. Advanced EHF is backward compatible with Milstar, which further increases both the Milstar and Advanced EHF capabilities.
Could you explain the unique features and capabilities of these satellites?
Sure. Several features make Advanced EHF unique. First, it is anti-jam. Second, it's built to survive and operate after a nuclear detonation. And it also is developed to have a low probability of interception and detection. Advanced EHF's capabilities include approximately 430 megabits per second capacity, 2 gigahertz uplink, and 1 gigahertz downlink, as well as an average of 194 areas of coverage.
Well, delivery to orbit is really just the beginning of a satellite's mission. Could you walk us through the next steps for AEHF-3?
You're completely right, Steve. This morning's mission is only the first step in getting this critical capability to our troops. Advanced EHF will go through 3 phases before it achieves its final orbit. The first phase is the launch phase, beginning with this morning's launch. Approximately 51 minutes after launch, Advanced EHF-3 will begin 4 orbit-raising operational burns utilizing a large liquid-powered engine, also known as the liquid apogee engine. After the last liquid engine burn, the solar panels will be deployed, and a set of smaller electrical engines, known as the Hall current thrusters, will begin firing near continuously to achieve the target orbit. This phase will last about 120 days. After that, the second phase will commence with 3 days of activation and checkout of the various communication antennas and subsystems. This is followed by about 45 days of on-orbit testing of the entire system. After all the systems have been tested and are determined ready for operations, the third phase will culminate when Satellite Control Authority of Advanced EHF-3 is transferred to the 14th Air Force.
Well, how exactly will the AEHF system be used to support our troops in the field?
Well, as you know, satellite communications have a much broader coverage area than traditional terrestrial line-of-sight systems, which makes it much more effective. Advanced EHF is an excellent asset because communication over the extremely high frequency range has higher bandwidth as well as lower probability of interception and detection due to the natural characteristic of being in a higher spectrum frequency with wider bandwidth. Advanced EHF is designed to provide more flexibility in bandwidth to the warfighter than MILSTAR, which means faster transmission of existing data, from voice, messaging, and some video to enabling types of data like full-frame video. These advances increase the troops' capabilities and give them more flexibility and bandwidth to perform the mission. Most importantly, Advanced EHF supports joint service interoperability with the Army, the Navy, Air Force, as well as the Marines and our international partners.
Well, Captain Farrar, thank you very much for all that great information. Now let's get back to the mission.
MR looks good. Centaur body rates controlling right down the middle. Range track shows good progress right down the middle of the corridor.
This is Atlas Mission Control at T plus 11 minutes 18 seconds into the flight into this third advanced EHF mission, and all systems continue to operate as expected. The mission is currently located over the Atlantic Ocean just east of Antigua Ground Station. Our next event, the first Centaur main engine cutoff, or MECO-1, is scheduled to take place in about 2 minutes. Here's Marty Malinowski.
Sure. And PU is controlling at nominal MR at this point in the mission. Tank pressures are stable. Battery voltages and currents look good. A little under 2 minutes remain in this burn. All systems continue to look very good. And Centaur should be within sight of Tigris at this point. Range track continues to show Centaur making good progress right down the middle. A little less than a minute remains in this burn. RL-10 continues to perform well. MR is right at nominal. And we have IAP vanish. And we have MECO. Engine shutdown looks good. CRD has been safed. 4S settling has begun. Fuel tank has been vented. Pressures look good. Quick check of the orbits shows Centaur is right where it ought to be. All parameters look good. As Centaur continues settling during this coast period, which will last for 470 seconds, the tank pressures are stable. Actually, we're seeing a fuel vent at this point. Storage bottle pressures look good. Bus and battery voltages are stable. RCS line temperatures look very good.
This is Atlas Mission Control at T plus 17 minutes into the flight. The AEHF 3 mission is currently in a coast phase over the Atlantic Ocean off the west coast of Africa. Our next event is the second start of the Centaur RL-10 engine. This event is scheduled to take place in approximately 4 minutes.
All Centaur systems continue to look very good. Our tank pressures are stable. Bus and battery voltages are good. The helium storage bottle is also stable, and we continue to settle in throughout the coast. And we continue to see our thermal conditioning firings on the RCS. Signatures look good. And Centaur pressurization has begun for the second burn. And Centaur has gone to dual branch pressurization on the fuel system. LH2 pre-start is underway. LO2 pre-start is underway. We have ignition and full thrust on the RL-10.
As Marty Malinowski just reported, the Centaur main engine has been restarted for the second of 3 planned Centaur engine burns. This burn will last approximately 5.5 minutes. The Atlas V continues to travel in a southeasterly direction over the Atlantic Ocean. Following our next event, MECO 2, or cutoff of the Centaur RL-10 engine, the Atlas V will cross over the African continent. Separation of the AEHF-3 satellite will occur over the Indian Ocean, just east of the island of Madagascar. Let's go back to Marty Malinowski.
The second burn duration is scheduled for 338 seconds. Tank pressures, storage bottle pressures, bus and battery voltages are all very good. Nice flat line. And PU is controlling near nominal at this point again. Engine performance looks very good. Hydrazine system is continuing to perform thermal conditioning firings. Line temperatures look excellent. RL-10 continues to perform well. All systems look excellent at this point in the burn. Engine continues to perform well as we see some light RCS firings. Tank pressures are stable. Storage bottle pressures look good. Bus and battery voltages are good as well. Body rates are controlling right down the middle. About 2 minutes remain in this burn. Engine performance continues to look good. RCS is operating as expected. Tank pressures are good. Centaur PU is controlling near nominal at this point. About 1 minute to MECO. All Centaur systems continue to operate well. Looking for main engine cutoff. And we have MECO. Engine shutdown looks good. We have 4S settling underway. Fuel tank pressures are being vented down.
This is Atlas Mission Control at 28 minutes into the flight. As Marty Malinowski just reported, we are in the second and final coast, and the mission continues as expected. Spacecraft separation is scheduled to occur in approximately 22 minutes. While we wait for the next event, let's take a look at a video highlighting the AEHF capability.
Advanced EHF is the follow-on to the operational Millstar system. There are currently 2 operational Advanced EHF satellites on orbit capable of providing assured, protected, and survivable communications to the warfighter. The Advanced EHF space vehicle, made up of the Lockheed Martin bus and the Northrop Grumman payload, is integrated and tested in Sunnyvale, California. After air shipment to the Astrotech facility in Florida, the fully tested Advanced EHF satellite undergoes launch-based confidence testing to verify vehicle health, check interfaces, and validate both ground and over-the-air telemetry. Spacecraft launch base final closeouts are performed prior to encapsulation in the Atlas V 5-meter diameter payload fairing. In parallel, the United Launch Alliance Atlas 531 booster and its Centaur upper stage are undergoing final preparations in the Atlas Vertical Integration Facility in preparation for mating with the fueled Advanced EHF space vehicle. The day before launch, the integrated core booster, 3 solid rocket boosters, Centaur upper stage, and the Advanced EHF space vehicle are rolled to the launch pad. When fully fueled, the complete launch stack will weigh slightly over 1 million pounds.
5, 4, 3, 2, 1. We have ignition and liftoff.
At launch, the main engine and 3 solid rocket boosters produce over 1.8 million pounds of thrust to begin the approximately 120-day journey of the Advanced EHF satellite to its initial geosynchronous test station on orbit. After 2 minutes of flight, the solid rocket boosters are separated from the core booster. 400,000 feet above the Earth and 3.5 minutes into the flight, the 2 halves of the payload fairing are jettisoned, and the space vehicle is fully exposed to the space environment as the booster stack continues to gain speed and altitude. After 4 minutes, the core booster separates. The Centaur upper stage completes 2 burns, and after 52 minutes of flight, the advanced EHF satellite reaches its highly elliptical parking orbit. The satellite will then begin 2 phases of orbit-raising operations to achieve geosynchronous altitude. These phases are the liquid apogee engine, or LAE phase, using chemical propellant, and the Hall current thruster, or HCT phase, which uses electric ion engines with xenon gas propellant. With completion of the 12-day LAE phase, the perigee will be raised to over 1,200 miles. The solar arrays and payload wings are deployed to begin the HCT phase of orbit raising. Over the next approximately 108 days, the highly efficient electric HCT engines will use slightly over 400 pounds of xenon to slowly circularize the orbit to the geosynchronous altitude. The HCTs are fired nearly continuously, only pausing to perform vehicle attitude updates using Earth and Sun sensors. This data and updated tracking data from ground stations will be processed in the factory to create an updated maneuver plan that defines the next HCT burns that are needed in order to follow the optimum ascent trajectory. Once the orbit-raising burns are completed, the satellite has reached its geosynchronous test location. The on-orbit checkout of the satellite bus and payload can then begin. During on-orbit testing, the advanced EHF satellite functionality is verified using the Mission Control System and operational terminals. Testing will take approximately 45 days to exercise payload and ground system performance. The third advanced EHF satellite is tested in a standalone configuration, then integrated and tested with the full advanced EHF Milstar constellation. After successful on-orbit tests, the Space and Missile Systems Center will recommend a transfer of Satellite Control Authority, or SCA, to the 14th Air Force. Upon acceptance, SCA will ultimately be transferred to the 4th Space Operations Squadron at Schriever Air Force Base. With the completion of orbital repositioning to its mission location, the third advanced EHF satellite is now ready for operation. Using RF crosslinks, it integrates with the operational advanced EHF Milstar constellation, greatly enhancing support to the warfighter. Advanced EHF will provide 10 times greater total capacity and offer channel data rates 6 times higher than that of the Milstar Block II satellites, permitting transmission of tactical military communications such as real-time video, battlefield maps, and targeting data. Integrating proven Milstar heritage technology with cutting-edge advanced EHF payload enhancements will greatly increase the communication connectivity and capability for the force services and our international partners, Canada, the Netherlands, and the United Kingdom. Advanced EHF provides survivable, assured, and protected communications for the warfighters.
This is Atlas Mission Control at T plus 34 minutes 24 seconds into the flight, and the Atlas 5 AEHF4 correction, the Atlas 5 AEHF3 mission and systems continue to operate as expected. While we take a brief break in commentary, let's rejoin Marty Malinowski as he reports mission progress.
And Centaur continues to look very stable as it rolls +1 degree per second with a 10% RCS duty cycle. Tank pressures are stable. Storage bottle pressures are good. Bus and battery voltages are stable as well. And seeing some minor data loss associated with Centaur's roll. Data's back. Looks good. And Centaur has begun its PTC roll reversal. And Centaur has completed the roll reversal, now rolling at -1 degree per second, continuing to settle at 10%. Tank pressures are stable, storage bottles are stable, bus and battery voltages are stable. And Centaur camera power has been applied. We do have video now from the forward-facing camera. All Centaur systems continue to look very good. Tank pressures are stable. Storage bottle pressures are as well.
This is Atlas Mission Control at T plus 42 minutes, 8 seconds into the flight. Welcome back to live coverage of the Atlas V launch of the AEHF-3 mission for the United States Air Force. Liftoff of the Air Force's third advanced EHF mission occurred at 4:10 a.m. Eastern Daylight Time. The mission is nearing the end of its second and final coast period. Our next event, spacecraft separation, is scheduled to take place about 9 minutes from now. I'm joined again by Captain Jennifer Farrar from the Air Force's Mills Satcom Systems Directorate. Captain Farrar, what's your role in the advanced EHF program?
Well, Steve, my responsibilities include the assembly, test, and launch operations for the advanced EHF satellite. This includes assembly of all the different components into one satellite system, as well as the testing of the system and preparations for launch operations.
Oh, what an interesting and challenging assignment. Captain Farrar, what is your favorite part of the job?
Wow, that's a great question. There's so many different fascinating aspects to the job. I'm not sure if I can narrow it down to one. If I had to choose one, it would have to be working with all of the technical experts on some of the most cutting-edge technology on the planet. It's truly awesome, and I find it so amazing that we're able to assemble such complicated and complex hardware that is literally out of this world.
What advice would you have for any young people in our audience that might have an interest in pursuing a career in science or technology, engineering, or math?
Well, I'd have to say to follow your heart. And if you find something interesting, definitely look into pursuing it. If you find how things work interesting, perhaps go into engineering. Or if you like physics, study science. Never let the challenge of something being difficult deter you from pursuing it. If you follow your heart and you're passionate about what you do, you'll find that you never have to work a day in your life.
That's great advice and very inspirational for our next generation. We're getting close right now to spacecraft separation. How does it feel to be so close to the deployment of this third advanced EHF satellite?
Oh, it feels incredible. There's nothing like it. I really can't put what I'm feeling into words. It's just amazing to be a part of this mission, especially knowing that this capability is going to enable the troops to have more capacity in everything that they do.
It's great to have your insight, and I really appreciate you being here. AEHF is a fascinating program and an incredible capability for our troops. We're just a few minutes away now from spacecraft separation, so let's get back to the mission.
All Centaur systems continue to look very good at this point in the mission. RCS line temperatures are at bottle temperature. Tank pressures are stable. Storage bottle pressures are as well. And Centaur continues its PTC roll at -1 degree per second. Tank pressures are stable. Storage bottle pressures look good. Coming up on the Centaur D-spin from the PTC. And Centaur has begun the D-spin. And the Centaur D-spin is complete. Body rates are controlling right down the middle. Tank pressures look good. Storage bottle pressures are as well. About 1 minute to
This is
spacecraft
Atlas
separation.
Mission Control at T plus 50 minutes, 3 seconds into the flight. All systems continue to operate as expected. Let's go back to Marty Malinowski for spacecraft separation.
And we have spacecraft separation.
Captain Ferreira, congratulations. We've just seen the successful delivery of the third advanced EHF mission for the United States Air Force.
Thank you, Steve. It's such a privilege to witness one of the most amazing accomplishments known to mankind. It's especially an honor knowing that it's because of capabilities like advanced EHF that keep our young men and women in the field safe, allowing them to support and defend our freedoms and our way of life. It's a wonderful day for the Air Force as well as for the United States of America.
And thank you for your participation today.
Thank you. It was my honor and privilege.
I'd also like to thank Marty Malinowski for his support of today's broadcast. We'll conclude our live coverage with another look at today's liftoff. For more information about the Atlas V, please visit our website, www.ulalaunch.com. I'm Steve Agate, and on behalf of the entire launch team, thank you for joining us and have a great day.